Hello friends, MoNaCo here, our third homework notes video. Today we're focusing on physical and chemical changes in matter. Students will be able to classify changes in matter as being physical or chemical in nature based upon observation of key vocabulary. So there's key vocabulary terms in this lesson that you're going to be looking for that tell us if we've had a physical change or a chemical change in the matter. So you're always going to be asking yourself if change is a matter of style or substance. A physical change is like a style change. You turn an ice cube from solid water, you melt it, it turns into liquid water, and you heat it up some more, it turns into steam. It's still water that we're talking about. The molecules themselves didn't change. They've only changed the phase or the style that they're in. Chemical change, on the other hand, is more of a substance change. It's when you have some object, some type of matter, and you've changed it into some other type of matter. So it's actually turning into something else. So a log turning into ash. Okay. So we got our little lead in here today. And how do matter and energy interact? Well, energy comes in many forms and can do different types of changes to matter. Sometimes that change is physical, other times it is chemical. For example, if you heat up water, it's going to turn from ice cube, if it was frozen, to liquid, and then to steam. If you heat up paper, which is a solid, it will eventually combust and burn and turn into ashes. So energy does different things to different types of matter. Sometimes it does a physical change, sometimes it does a chemical change. Our focus here is learning to classify changes in matter as being physical or chemical in nature. Okay? So let's check out the notes. So matter is always changing. Ice in your drink melts, wood in your fire burns. It's kind of like how the universe runs the show. Matter changes. Physical changes are the simplest type of matter, and it's a change doesn't alter the chemical properties of that substance. For like example, cutting paper. If you take a piece of paper, you chop it down into little bits, it's only a change in size or shape. Same material, but it's in a different form. It looks different, but it is actually chemically the same. It can go back to its original state. And usually no energy is produced as a byproduct. Cutting up a piece of paper doesn't release energy, it just changes the paper into smaller pieces, all of which are molecularly identical to the original. So that is a physical change. The example of ice melting to become a liquid is one of the best physical changes that we're going to be talking about this year. It's our consistent reminder. Okay, so let's look at some chemical changes. This is a reaction in which the composition of a substance is changed. Okay, so for example, it's like something like rusting. Okay, the iron in your car literally turns into a different compound called rust, iron oxide, and is not as strong as the original substance. It's not the same as the original substance or matter. And usually energy is produced in this type of reaction. Okay, some of the examples obviously that we started with is a piece of wood burning. I came across this acronym, FARTS, to help you identify if a chemical change has occurred. So physis means if the reaction is producing bubbles, that's a new substance. Gas is being made, so that would be a chemical reaction or chemical change. Aroma, that means something that smells is being produced, a new chemical compound, and it's coming into your nostrils. A replacement, if you're replacing one element with another in a reaction, that is definitely a chemical change. Now, temperature is a little iffy because you might think, well, hey, mister, I'm going to put heat into this ice cube and it's going to turn from a solid ice cube into liquid water. When we're talking about temperature here, did the reaction itself produce a temperature change? Meaning, did you mix two things together and then all of a sudden it got colder or hotter? Not did you put it over a flame or did you put it in the fridge? Did the reaction itself create the release of energy? Or in general, did a new substance get made? That's how you know if you've got a chemical change. So let's classify some changes. Burning toast. Well, toast was bread, but if it burns, it gets brown, nasty stuff all over it. And if you think about it, that produces an aroma. It could produce some smoke and steam, so it's probably a chemical change. Making ice cubes. Well, I would be making ice cubes from water. And if I take water and I put it in the freezer, it gets colder and it turns into a solid. But it's still water. So if its identity didn't change, it must have been a physical change. Lighting a candle. Well, if you think about a candle, it's there, it's got the wick, it's got the wax, and if you light it on fire, it burns. And the candle gets shorter, the wick turns black. So lighting a candle, burning, is going to be a chemical change. The candle burns up and goes away. It doesn't turn into another candle somewhere else. I think this one's obvious. Spoiling milk, that's that aroma. If that milk, you give it a good whiff, stinky spoiled milk, that tells you that a chemical change has occurred. It is no longer milk like you bought at the store. It is something else and new. Making Kool-Aid. Well, you take a powder, which you could eat by yourself. You could put the Kool-Aid powder in your mouth and get the flavor. And you mix it into water, which you could also eat by yourself, and it's just clear water. So if you mix the two together, chemical change or physical change? Did the identity of the Kool-Aid change, or did it just get dissolved in the water? There's some arguments on both sides of the fence for this one, but I personally believe that dissolving is a physical change. If you evaporated all the water off, you'd be left with the Kool-Aid down at the bottom, the powder again. So that's why I feel that that is a physical change and not a chemical change. Because you leave your Kool-Aid on the shelf for too long, it'll evaporate all the water out, leaving the sugar and flavor residue at the bottom, just like they were at the beginning before you mixed the Kool-Aid. Okay. So you should now be able to differentiate between physical and chemical changes. So just remember, is it a matter of style or is it a matter of substance? Did the thing change shape or phase, or did it actually change identity? That's going to help you figure out if it's a physical or a chemical change. So focus on using those verbs in the descriptions to help you figure out if the change is physical or chemical. I have just two more slides to show you. Generally speaking, some nice chemical change overview. Okay, gases could form, heat could be produced, color could also be affected. Chemical change involves mixing items together to create a reaction. Materials could be affected in many ways as a result of the chemical reaction. But on the other side of things, a physical change is reversible. You could rip, tear, grind, crush, melt, freeze. The identity of the stuff that we have might change shape, but it doesn't change identity. Condense, evaporate, cut objects to have a physical change. There are many ways to physically change something. There are only a few ways to chemically change something. So thanks for listening. See you later.